This is the first of a set of 3 videos discussing how to simplify rational expressions. Rational expressions are simply fractions that have algebra in them, so there's lots of variables, generally x's in our examples that we'll be looking at. But since they are really just fractions, we're going to be comparing what we do to the kinds of fractions that you're familiar with that are just numerical. In this video, we'll be talking about reducing to simplest terms, multiplying, and dividing rational expressions. 2 preliminary remarks, though. First of all, I will assume that you're familiar with factoring because we are going to need to factor a lot of expressions in order to reduce our answers, and it will help make our multiplying and dividing much simpler. Second preliminary remark. When we have numerical fractions, you may recall that we can never have a 0 in the denominator. And that's going to be true for algebraic fractions as well, but it might not be as obvious when we have a potential problem. So whereas in a numerical fraction, it's easy to see, oh, there's a problem, I'm not allowed to have that 0 down there. In an algebraic fraction, we might have something that looks like this. And we might not realize I potentially have a problem. When might I have a problem? Well, whenever this denominator could possibly equal 0. So I'm going to need to exclude the values of x when that x squared minus 49 would equal 0. In order to see specifically what x values are problems, I often need to factor. So I'm going to factor that expression, and I now can determine that I have a problem when x equals negative 7 or positive 7, because at negative 7 or positive 7, that expression x squared minus 49 will equal 0. Now we may not always say this explicitly when we write an algebraic fraction like this. We might not say, make sure you do not permit x to equal negative 7 or positive 7, but it will be understood. So have that as kind of a thought in the background whenever you're looking at a fraction that has an algebraic expression in the denominator, that we are assuming that we will not permit the denominator to equal 0. Now let's look specifically at how reducing algebraic fractions is really just like reducing fractions that we had in arithmetic. You might recall that what we do in order to reduce a fraction that is not yet in simplest terms is we divide the numerator and denominator by some common factor. We often don't write it out explicitly, but what we're really doing is we're factoring each of the numerator and denominator, and then we are dividing out whatever factors are common. So when we do that, we get a simplified or reduced version of our fraction. How does this work with algebraic fractions? Well, let's look at the same one we just were considering a moment ago. This is not yet in simplest terms. If I factor that denominator, I see that both the numerator and denominator have a factor of x plus 7. So I'm going to divide both the numerator and the denominator by x plus 7. Now, remember that when I divide the numerator, x plus 7 divided by x plus 7, that result is 1. So I've got a 1 in the numerator now, and I've got x minus 7 in the denominator. So now I have a reduced version of my algebraic fraction or rational expression. One thing to be cautious of: make sure that you always factor before you attempt to reduce, and that you are really dividing. Sometimes it's tempting to see something that looks the same on the top and bottom of a fraction and think that we can just cross out things that look similar. Sometimes students will try to cross out an X here and one of the X's here, but that's not dividing. We have to make sure that we have factored and then that we are dividing out common factors. Factors are things that are multiplied, so x plus 7 times x minus 7, those things are being multiplied, and so I can divide out the x plus 7 and be left with x minus 7. Now let's recall how to multiply fractions. If we are multiplying numerical fractions, such as 2/3 times 6/5, the general procedure is to multiply the numerators and multiply the denominators. And then if we need to, we can reduce at the end by factoring. Here I'm going to factor a 3 out of both my numerator and denominator and divide by 3. So I get 4/5 at the end. Now sometimes we can simplify before we get to the end in this multiplication procedure. For instance, if I had noticed back at the initial step here that there was a common factor of 3 in the 6 and the 3 here, I could have done this. 2/3 times 2 times 3 over 5. I could have divided out that common factor of 3 back at this earlier step. It's the same common factor being divided out. It's just being done earlier. And that would give me a simplified version of the fraction. It would save me getting these large numbers of 12 and 15 because I would have already divided out the common factor. It would keep things smaller. This is a strategy that is even more helpful when we are multiplying algebraic fractions. So let's look at an example where we have algebraic fractions. And we definitely want to factor and divide out anything that is in common before we multiply. So I'm going to multiply this pair of fractions here. If I did not factor and divide out common factors, that numerator would have something in terms of x to the 4th in the top and also in the bottom, so that would be really ugly. We definitely want to try to avoid that. So I'll factor everything. X squared plus 5x plus 6 factors as x plus 2 times x plus 3. This denominator factors as x plus 3 times x minus 2. This numerator and this denominator. Okay, so now I've got everything in factored form and I can look for common factors to divide out. I always have to divide one from the numerator, one from the denominator, because that's how we reduce fractions and keep them equivalent. Okay, so here I see, for instance, I've got an x plus 2 here and here. I'll divide those out. I actually have x plus 3 on both the top and bottom of that same fraction. And over here also I have an x minus 3 on the top and bottom of the same fraction. It doesn't really matter whether I divide this pair of x plus 3 and x plus 3, or I could have divided this pair. It doesn't matter for the end result. Well, that looks much, much better. In fact, what that means is that my final answer is just x plus 3 over x minus 2. Okay, finally we're going to do an example of division. So again, referring back to how we divide numerical fractions, hopefully you recall that the procedure is generally to multiply by the reciprocal of the divisor. So you change this division, 2/3 divided by 5/6, into the multiplication 2/3 times 6/5. And then we multiply as usual. Now, also as before, it's often to our advantage, once it's a multiplication problem, to go ahead and factor, look for common factors that we can reduce ahead of time, and just keeps our numbers smaller. So we're going to do something analogous here with our algebraic fraction example. Okay, so as before, the very first thing we're going to do is change this into a multiplication problem. We're going to multiply by the reciprocal of the divisor. Okay, now I'm going to factor and hope that I can cancel out some common factors, divide out some common factors, because as with my multiplication problem, if I can't do that, I'm going to have something to the 4th power, which I prefer not to have. Okay, there's all of the factored forms. I see I have a common factor of x plus 1 here and here, common factor of x plus 2 here and here. Okay, that looks like it. So, but that's still much better than it could have potentially been. I am not going to bother to multiply back out these factors. We generally leave our final answer in factored form like this, although it would be correct to say go ahead and multiply out those, the 2 on the numerator and the 2 on the denominator. It's just a matter of what you're comparing it to or what you want to do next. So either of these would be a correct way to leave your final answer.